All right, so this is Simplifying Rational Expressions, section 5.7 in Al Grosch's book, Developmental Math 2. Let me just start off by saying that I think in different versions of this book, this is actually section 5.8, but it doesn't matter. All the questions are still the same. So just look for the section that is Simplifying Rational Expressions. All right, a rational expression is just a fancy word for a fraction. Most of the time it applies to a fraction that has variables in it, but we're going to start off with a rational fraction, a rational expression that does not have any variables in it, so that we could just review how to simplify. Simplify just means reduce. So we're going to get these numbers down to as small as possible. And this is one way to do that by listing the prime factors of the numerator and the denominator. We can see that some of these factors will cancel. And that's what's happening down here. When you have a factor that's the same in the numerator and denominator, they reduce to make 1. 5 over 5 is just 1. So by doing this, you're just identifying where the ones are. So this would just be 2/7 times 1, which is 2/7. So I know that with standard proper fractions, we learned how to reduce by dividing the top and the bottom by a common factor and all that. But by listing out the factors and reducing them like this, you're introducing what we will do with algebraic rational expressions. So when we come down here, that's the way we're going to practice it. We're going to list out prime factors. So let's zoom in a little bit so we have room. So the prime factors of 45, and you can use your tree to find these if you need to, will be 3 times 3 times 5, 45. And the prime factors of 63 will be 3 times 3 times 7. And you find those, remember, by using the tree. 9 times 5, 3 times 3. I'm hoping that you guys will remember this. You can do this off to the side by yourself. And now we will just reduce off the ones that match. Now, I want to clarify here. This is not making zeros. These are making ones. 1 times 1 times 5/7, which is just 5/7. Because the fact that these are making ones is important. We don't usually write the ones. You can if you want. These are all going to be ones now, if you need to remember that, because there's going to come a time when there's nothing left but those ones, and you have to remember those ones are still there. All right, let's look at number 2. We're going to simplify 60 over 140. So if you need to use the tree, let's do 6 times 10, 2 times 3, 2 times 5. So we'll have 2 times 2 times 3 times 5 for 60. For 140, that's 10 times 14. 10 is 2 times 5. 14 is 2 times 7. So we'll have 2 times 2 times 5 times 7. And then we will just reduce the factors that match. And we're left with 3 in the numerator and 7 in the denominator. So 3 over 7. Okay, number 3, now we're going to start to add some variables. So we're going to use prime factors again, and we're going to break this down. I'm actually going to scroll it over here so I have plenty of room to write. First of all, 25 is 5 times 5. So we'll start with 5 times 5 for 25. X to the 4th just means there are 4 x's and a y. In the denominator, 10 is 2 times 5. There are 2 x's and 5 y's. Now, we've done this before. We did this in chapter 4 when we learned exponent rules. We can reduce those 5. We can reduce a couple of x's, and we can reduce one of the y's. So it looks like what we're left with in the numerator is 5x squared, and in the denominator, 2y to the 4th. So this is just reducing. So we'll do the same thing with this one. 14 is 2 times 7. We have a to the 7th and b to the 4th over 20, which is 4 times 5, or 2 times 2 times 5, a cubed b to the 5. And we can reduce a 2, 3 a's, and 4 b's. So it looks like we're left with 7 a to the 4th over 10, 2 times 5, b. All right, that last page was a review of some stuff that we did in Chapter 4. This page, we're going to look at some rational expressions that are a little bit different. These rational expressions have addition and subtraction in the numerator and denominator. So the only difference being here is the way we factor them. We're not going to just string out a bunch of multiplication, because with the addition and subtraction, now we have to use all the factoring methods we learned for polynomials. And so you can take a look at this rational expression, and this is its factored form over here. Now I'm going to say this, if you don't remember how to get from this 3x squared minus 8x minus 3 to this, you're going to need to go back and review your factoring. And the denominator here is the difference of squares, so these are its factors. Once you get the factors, then you're going to reduce any factors that match. Those two are identical, so they reduce off just as if they were monomials. And we're left with then 3x plus 1 over x plus 3. And I want to let you know here, these x's are not going to cancel because of the plus and minuses. When you have things that are part of terms, they do not cancel off. These 3's will not cancel, and these x's will not cancel. Here, when we're factoring, we're going to end up with binomials now that will cancel. Sometimes GCFs, but mostly binomials. So we're going to look down here. And again, if you don't remember your factoring, go back and review those lessons. In the numerator 2x minus 14, the first thing we always look for with factoring is a GCF. So the GCF in the numerator here is 2. And when we divide off the 2, we're left with x minus 7. The denominator, on the other hand, does not have a GCF, but it is the difference of squares. So when we factor the difference of squares, remember we take the square root of the first term, the square root of the second term, and one's a plus and one's a minus. And now we can reduce off these x minus 7's. We're left with 2 over x plus 7. On number 2, we have trinomials. So we're going to use our trinomial factoring. So x squared is x times x. We've got plus signs, factors of 2 that add to make 3. In the denominator, x times x, we have a plus sign and a minus sign. So factors of 2 that subtract to make 1. And now which factors will reduce? X plus 2 and x plus 2 are identical. We're left with x plus 1 over x minus 1. And again, I'm going to say this, these will not cancel. If you have things being added and subtracted, terms do not cancel, only factors. If it didn't cancel back here, it's not going to cancel down here. Okay, we have some more practices here. This is really just practice in factoring, folks. It's all about factoring and reducing. So I'm actually going to write my factors down here. The numerator is the difference of squares. So we're factoring x plus 2, x minus 2. The denominator is a standard trinomial. So when we factor that, let's see, we're going to have a minus and a plus. So we'll be looking for factors of 8 that subtract to make 2, not 6. Four and 2. Which ones match? Well, what is this sign here? This is a minus. So x plus 2 and x plus 2 match. So we're left with x minus 2 over x minus 4. And I'm going to say it again. These are not going to cancel, and these will not reduce. Terms do not cancel, only factors. It looks like in the most recent edition, this is not the same question. So I'm going to X out this question. What I see instead is x squared plus 5x plus 6 over x squared minus x minus 6. So I'm going to write these factors down here. These are both standard trinomials, so we should be able to factor in one step. X squared is x times x, plus plus. Factors of 6 that add to make 5 will be 3 and 2. In the denominator, again, another standard trinomial. This time we'll have minus and plus. Factors of 6 that subtract to make 1, also 3 and 2. And it looks like the x plus 2's will cancel. So we're left with x plus 3 over x minus 3. Again, don't reduce these. If it didn't reduce off back here, it isn't going to reduce down here. You cannot reduce off terms, only whole factors. On number 5, the numerator is 2 terms. We always look for a GCF first, so there is a GCF in the numerator of 6. When we factor that off, we're left with x minus 5. The denominator, 5 minus x, does not factor. There's no GCF. It's not the difference of squares. I'm going to put parentheses around it just to remind me that it is a binomial. I cannot reduce off pieces of it. I can only reduce the whole thing as a whole. Now, 5 minus x and x minus 5 are not identical, but they can cancel if you recognize that they are opposites. This x is positive, this one's negative, this 5 is negative, this one's positive. They are opposites. I'm going to write this over here. Opposites. When you cancel opposites, just as an example, if I cancel 3 and negative 3, they're opposites. I can reduce them, but it doesn't make 1. It makes negative 1. When you cancel these opposites or reduce them like that, you're left with a negative 1. You can't just forget about them like we do before with just positive ones. You need that negative 1, and I usually just put it right up here in the numerator. And now we're left with 6 times negative 1, which is negative 6. So it's okay. It's okay to reduce opposites like this. Just don't forget about this negative 1. We do it all the time when we're reducing fractions. So let's try this. 6x squared minus 13x plus 6 over x squared plus 4x plus 4. That's what the book says. I must have an old. I'm trying to do this to match the most recent version of the book. But my pages are old. So we're trying to make corrections as we go. All right. So 6x squared minus 13x plus 6. We're going to have to use the square root method on. So we'll multiply the first and last terms by 6. So we'll have 36x squared minus 13x plus 36. Square root the first term. Put your signs in. So we're looking for factors of 36 that add to make 13, and that would be 9 and 4. Divide by the GCF. We end up with 2x minus 3, 3x minus 2. And I'm going to say this again. If you don't know how to get through this, you need to go back and review the factoring lectures. So that will be the numerator. 2x minus 3 times 3x minus 2. The denominator is x squared plus 4x plus 4. So when we factor that, it's a standard trinomial actually. Just going to write it right up here. X times x plus times plus 2 times 2. It looks like nothing is actually going to reduce here. None of these match. So no reducing here. So this is already simplified. I'm wondering if the old version with this trinomial might have reduced some, but that's okay. This is what's in the newest version of the book, so this is what we're going to go with.